everyone, and welcome to the Lesson 17.1 Dilations video. A dilation is a transformation that changes the size of the figure by a scale factor k. So up until this point, we have only talked about rigid motions. Rigid motions are transformations that do not change the size or the shape of the figure. So translations, reflections, rotations are all rigid motions because they do not change the size or the shape of the figure. A dilation is not a rigid motion because it will end up changing the size of the figure by a specific scale factor. So if you look at the picture I have below, quadrilateral ABCD, the red quadrilateral, got dilated in order to form the green quadrilateral ABCD prime. I have already wrote down the coordinates of each vertice. And if you notice, the quadrilateral coordinates ABCD were all divided by 2 in order to get the coordinates of quadrilateral ABCD prime. So -4, 4 became -2, 2, 0, -2 became 0, -1, and so on. The new coordinates are half the coordinates of the original quadrilateral. So I'm going to write that down for number 3. The coordinates of quadrilateral ABCD prime are half the coordinates of quadrilateral ABCD. So in order to express this as a function, we are going to say that for every point xy, we multiply x and y by 1/2. 1/2 is the scale factor of this dilation. So anytime you need to express a dilation as a function, it will always be of the form xy becomes kx, ky, where k is the scale factor. In order to determine what k is going to be, we're going to place a new coordinate over an old coordinate. For example, if you look up at the coordinates of A, and you specifically look at the y values, 4 and 2, I know that the prime one is the new one, so I would place 2 over 4. And 2 divided by 4 can be simplified to 1/2. And that's how we got the scale factor for this transformation. Now, if you notice, every single point has the same scale factor. So it doesn't matter which point you use to place a new one over an old one in order to find your scale factor for the dilation. Let's try another one. Question 5 says label the coordinates for each triangle above and express the transformation from ABC to A prime, B prime, C prime as a function. So they want us to fill in xy, and I need to figure out what the scale factor is going to be. Well, as we said in the last example, I need to pick one set of new and old points and make this ratio. Since every single pair of points has the same scale factor, I'm just going to pick the C's. So C prime is at 4, 2, and C is at 2, 1. If I just look at the x values, 4 divided by 2, new over old, I get that my scale factor is 2. And that's what I'm going to place as my scale factor, 2 and 2. So for each point xy, we multiply both the x and the y by 2 to go from the purple triangle to the green triangle. So if you noticed in the first example, the scale factor was 1/2 and the quadrilateral was reduced. The quadrilateral reduced in size when the scale factor was 1/2. In this last example, our scale factor was 2, and our figure expanded. It enlarged. We went from the purple triangle to the green triangle when our scale factor was 2. So, the scale factor determines whether the transformation is an reduction or is an enlargement or a reduction. So just by looking at the scale factor, we can determine if our figure is going to get bigger or smaller. If k is bigger than 1, it will be an enlargement. So for example, when k was 2, our triangle got bigger. And if k is bigger than 0 but less than 1, it will be a reduction. So when our scale factor was 1/2, we saw that the quadrilateral got smaller. Now if k is exactly 1, we know that anything times 1 is just itself. So if your scale factor is 1, the figure will not change in size, because multiplying by 1 will not change the points at all, meaning they'll be exactly the same. So, in this next example, it says rectangle ABCD has the following coordinates, and it's mapped onto rectangle ABCD prime by a dilation with a scale factor of 1/2. What are the coordinates of rectangle ABCD prime? In order to do this, I am going to take every single pair of points and I'm going to multiply by 1/2, which is my scale factor. Zero times 1/2 is just 0, and 6 times 1/2 is 3. 4 times 1/2 is 2, and 6 times 1/2 is 3. 4 times 1/2 is 2, and 0 times 1/2 is 0. And once again, 0 times 1/2 is just 0, so that point will remain the same. And these would be my new coordinates. Now, without even graphing, I can tell if the dilation is going to be an enlargement or a reduction just by looking at the scale factor. Since the scale factor is less than 1, I know this is a reduction. And the last thing we are going to talk about in this video is a center of dilation. A center of dilation is the point about which all points are enlarged or reduced. Up until this point, we've assumed that the center of dilation is the origin. When the center of dilation is the origin, that's when we multiply all points by the scale factor, and all of the points are reduced or enlarged about the origin. But if our center of dilation is a vertex of the figure, not the origin, there are different steps we have to take. Step 1 Step 1, find the slope from the center to each remaining point. So from the center of dilation, we are going to count the rise over the run to each remaining vertex. Then we are going to multiply the scale factor to each slope. So let's try this in an example. I'm first going to plot the points, -2, 4, 1, 2, and 1, 0. And it says dilate this triangle with a scale factor of 2, meaning our figure is going to get bigger. And the center of dilation is -2, 4. So my center of dilation is A. My first step is I need to find the slope from A to each remaining point. So the slope from A to B, and I count rise over run. So it looks like I go down 1, 2, and I go over 1, 2, 3. So that's the slope -2 over 3. And then I need to find the slope from A to C. So from A to C, it looks like I go down 1, 2, 3, 4, and over 1, 2, 3. That is step 1, finding the slope from the center of dilation to each remaining point. Step 2 is multiply the slopes by the scale factor. So I'm going to multiply each slope by the scale factor of 2. So times 2, times 2, times 2, times 2. -2 times 2 is -4, and 3 times 2 is 6. -4 times 2 is -8, and 3 times 2 is 6. And now, these are my new directions for how I move. So from A, I'm going to go down 4, 1, 2, 3, 4, and over 6. 1, 2, 3, 4, 5, 6. This will be my B prime. And then to get C prime, I'm going to go down 8, 1, 2, 3, 4, 5, 6, 7, 8, and over 6. 1, 2, 3, 4, 5, 6. And if you noticed, it's like I put my pen down on point A and stretched my triangle from A by a scale factor of 2. That's why A stayed the same and my triangle was stretched from there. I would like you to try this practice problem on your own, so please pause the video, try this practice problem on your own, and then unpause the video to see if your example matched mine. All right, welcome back. I started by plotting the points of x, y, z. Since z is my center of dilation at -2, -3, I found the slope from z to x and from z to y. From z to x, you go up 2 boxes and over 1 for a slope of 2 over 1. And from z to y, you go up 1 box and to the right 2 boxes for a slope of 1 over 2. Then, since my scale factor is 3, I'm going to multiply my slopes by 3. So 2 times 3 is 6, and 1 times 3 is 3. And 1 times 3 is 3, and 2 times 3 is 6. These are now my new directions on how to move from z. So starting at z always, I'm going to go up 6 and to the right 3. So 1, 2, 3, 4, 5, 6, and over 3. 1, 2, 3. This is my new x prime. And from z, I'm then going to go up 3. 1, 2, 3, and over 6. 1, 2, 3, 4, 5, 6. And this will be my dilated triangle. So remember, dilations are different from the other transformations we've talked about because they change the size of the figure. Dilations are not rigid motions. When we dilate centered at the origin, we multiply the scale factor to every single point, the x and the y. And when we are dilating not centered at the origin, we need to find the slope from the center to each point, and we multiply the scale factor by the slopes. I hope this video helped. Please let me know if you have any questions, and I will see you in class.